JS file. And we need to give it the attribute type equals module because we used imports. And let's save so we run this test. So we'll open our test page and you can see that the cart was rendered onto this test page. And we still have our Jasmine results at the bottom here. So you notice that when we render this, it didn't load any CSS or images. And this is okay because we can't really use code to check if the page visually looks correct. However, we can use this to check the contents of the page, like if the products and the quantities are correct. So first, our cart has 2 products in it. So we can check if there were 2 products that were rendered on the page. Let's go back to our tests. And let's take a look at the order summary.js file. And when we render the order summary, we scroll down. For each product in the cart, we create an element with the class cart-item-container. Since we have 2 products in the cart, let's check that we created 2 of these elements on the page. So we're going to open the order summary tests.js file. And then in the first test, at the bottom of this test, we're going to add some lines and we're going to check if we have 2 of these elements. To do that, we can use the DOM using document.query selector all brackets and a string. And we could select the class cart-item-container. However, this class is used for CSS. So remember, if we're going to use a class in JavaScript, we start with JS-. Let's add a new class to this element that we can use for the tests. We'll add js-cart-item-container. So now we're going to select all the elements with this class using .js-cart-item-container. And let's save the order summary.js file. And then down here, we're going to check if we have 2 of these elements on the page. So again, to check something in our tests, we're going to use the function expect, open bracket, and let's create a new line to make it a little cleaner. And at the end, we'll give a close bracket like this. And this code gives us an array of elements. So here, we're going to check if the dot length of this is equal to 2. So expect gives us an object which has a method called .toEqual, brackets, and 2. So this checks if we have 2 of these elements on the page. So let's save, and then check the test page, and scroll to the bottom, and you'll see that this test passed. So that's how we check if we rendered the page correctly. Next, let's do another check of what we rendered on the page. So another thing we can test is if the product quantities are correct. So first, we need to get this quantity element into our tests. So we'll go back to our code, and then inside the HTML of the order summary, we're going to scroll down until we see a div with the class product-quantity, and we're displaying the quantity here. So now we're going to take this element, put it into our test, and check that the quantity here is correct. So to do that, let's give another class to this element so we can select it using JavaScript. So here we'll add another class, js-product-quantity. And we want to check the quantity for each product. So we need to identify which product this is for. We can do that by adding a dash to this class and then inserting, using $ and curly brackets, the product's ID, which is the matching product dot ID, and save. And now let's get this element into our tests. So down here, we're going to document dot query selector brackets, and we'll give it a template string because we're going to insert a product ID. So we're going to select this class using a dot js dash product dash quantity dash and then insert the product ID. So in our cart, we have two products, and let's start with the first product ID. Now, to make this easier, let's put this string inside a variable so we can reuse it below. So above this, let's create a variable with const, call it product ID 1 equals, and we're going to select this ID and then right click, cut, and then up here, right click and paste. And then we're just going to use this variable down here, product ID 1. And then when we're getting this element into our code, we're also going to insert the product ID, which is product ID 1. So now we're going to check if the text inside is correct. So for the first product, we have a quantity of 2. So the text inside this element should say quantity : 2. So to check this, at the bottom of our test, as usual, we're going to use the function expect, open bracket, and a new line. And then here we can remove the semicolon and close bracket. And we're going to get the text inside this element. Now we're not going to use .inner HTML because this element contains a bunch of HTML inside, but we only want the text. To get just the text, we're going to use the property .inner text. So we expect the text inside this element to contain quantity : 2. However, this element also has some other text like update and delete. So we just want to check if quantity 2 is somewhere inside this element. So how do we check that? To do that, we're going to use a different method of expect called .toContain and brackets. And we're going to give it the string that we want to check for, which is capital Q quantity : 2. So the toContain method checks if this value contains this string. So they don't have to be an exact match like with toEqual. As long as quantity : 2 is somewhere in this element, then this expectation will pass. And this is exactly what we need when this element has some extra text that we don't really need to check. So now let's click our test file and save and open the test page. And scroll to the bottom, and you'll notice that the test passed. So for the first product, we're displaying the quantity of 2 correctly. Let's also check the quantity of the second product. We'll go back to our tests, and just like before, let's create a variable to store this ID. So we'll create a variable with const product ID 2 equals, and we'll select this ID and right click, copy, and then here, right click and paste. And then we'll remove this and use the variable product ID 2. And then at the bottom, we're going to get the quantity element for product 2. So let's just copy this code because it's very similar. We'll select it, right click, copy, and then down here, right click and paste. So this time we're going to get the quantity element for product ID 2. And in our cart, product 2 has a quantity of 1. So down here, we're going to check if the text contains quantity : 1 and save. And let's open our test page and scroll to the bottom, and this test passed. So we're displaying the quantity of both products correctly on the page. The second thing we can test in an integration test is how the page behaves. For example, on this page, we can click the delete link to remove a product from the page. So let's create a new test to make sure that the delete link behaves correctly. We'll open our test code, and at the bottom, we're going to create a new test using the function it and brackets. We'll give it a name, and let's describe what the behavior should be, which is removes a product, comma, and a function, brackets, arrow, and curly brackets. Now let's do the same setup as the first test. So we start with 2 products in the cart. So we can select from load from storage, and we'll select all of this code up here, and then right click, copy, and at the bottom, we're going to right click and paste. So this will set up the HTML element that we need for the order summary, as well as the cart. And after this, let's render the order summary using the function render order summary and brackets. So once we've displayed this on the page, we're going to get the delete link and click it. So first, let's get the delete link into our code. So we'll go to the order summary.js file, and inside the HTML, we're going to scroll down a bit till we see the delete quantity link. And let's test the delete link for the first product in the cart. So first, we need to add a class to this element so we know which product this is for. So here, we're going to add a class js-delete-link- and insert the product ID, which is the matching product .id. And I'll add a new line to make the code a little bit cleaner. And now we can save. And then down here, we're going to get the delete link for the first product ID. So at the bottom, we use document.querySelector brackets, and we'll give it a template string because we're going to insert the product ID, and we'll select this class using .js-delete-link- and then insert $curly brackets product ID 1. And now we need to click this delete link to remove the first product from the page and from the cart. To click an element using code, we can just get it using the DOM and then use the method .click and brackets. So this will click delete on the first product and remove it. So let's save and take a look at our test page. And unfortunately, this test failed. So let's take a look at the details of the failure to figure out how to fix it. So it's telling us that we cannot set properties of null. This means that a value in our code is null, and we're trying to give it a property. And here, it will tell us which line we got this error from. So this error happened in our test file, and the line that created this error was in order summary.js on line 132, or whatever line that you see here on your page. So inside our code, we're going to open order summary.js, and I'm going to scroll down to line 132. And you can scroll down to the line that you got on your page. So this line of code is actually part of the code that we run when we click delete. So remember that when we click delete, we also update the payment summary on the right side of the page. And that's what this line does. Now, the reason this is not working is if we open the payment summary.js file and we look at what this does, at the bottom, after we generate the HTML, we try to put the HTML in an element with a class js-payment-summary. And this element does not exist in our tests. So one way to fix this is to add this element to our tests. So let's open our tests again. We'll open the order summary test.js, and then we'll scroll up. And then here, when we create the order summary element, we're also going to create the payment summary element. So we'll create a less than div greater than, less than slash div greater than. And here, we'll give it a class equals double quotes, and we'll give it the class that the payment summary needs, which is js-payment-summary, and save. So now that the payment summary element is set up, we can open our test page, and our tests should no longer have a failure. So you also notice that the payment summary got rendered or displayed on the page. Okay, so in our tests, we only clicked the delete link for the first product, but we didn't actually check if the page looks correct. And that's what it shows here with this yellow dot. This test has no expectations yet. So let's go back to our test and add some expectations at the bottom. So we'll scroll down, and down here, after we click delete for the first product, we expect that there's only one element left on the page for the cart. So in our first test, we actually had a check for this. So we can scroll up, and here we check if we have two cart item containers on the page. So let's just reuse this check because it's very similar. We'll select it, right-click, copy, and then down here, we're going to right-click and paste. And this time, we only expect one cart item container to be left on the page. So we'll change this to 1. So we'll save, open the test page, scroll down, and now this test passed. Let's also do a more detailed check. So we're going to check that the first product is no longer on the page. We'll go back to our tests. And then down here, we're going to get the cart item container for the first product. We use document.querySelector, brackets. And to get the element for the first product, we're going to open ordersummary.js and then scroll up in the HTML until we find the cart item container element. And we're going to look for this class right here, which tells us which product this element is for. So in here, we'll give it a template string because we'll insert the product ID, and we'll look for this class using a .js-cart-item-container- and insert the first product. So product ID 1. And because we removed this product from the page, we expect this result to be null. So we'll use the function expect, open bracket, and a new line, and then down here, a close bracket, and we'll use the method .to equal brackets, and we expect this to be null, and save. Let's also check that the second product is still on the page because we didn't delete it. So let's just make a copy of this check. We'll select it, right-click, copy, and then here, right-click and paste. And we'll get the element for product ID 2 this time. And we want to make sure that this exists so that it is not equal to null. In Jasmine, to check if something is not equal to, expect gives us another property we can use called .not. So if we use the .not property, it will check the opposite of whatever is next. So this will check if this value is not equal to null. So remember, the code for Jasmine is designed to read like English. Let's save and check the test page and scroll down. And this test passed. So we're displaying the correct products on the page after deleting. Now there's one more thing that we need to check here, which is after deleting, is the cart array itself updated? So we'll go back to our code and add that check. So first, we need to import the cart so we can use it in this test. We're going to scroll up to the top. And we're already importing from cart.js. So we'll add a comma and import the cart. And then at the bottom, we're going to check if the cart is correct. So the cart started out with 2 products inside. After removing the first product, the cart should have a length of 1. And the remaining product should have product ID 2. So let's add both of these checks at the bottom. So we'll scroll back down and we'll use expect brackets and we'll check if cart.length.to equal brackets 1. And we'll also expect brackets and we'll check the first product in the cart, which is cart square bracket 0, and we'll check its dot product ID dot to equal, and it should equal product ID 2. So product ID 2. And save. So let's open our test page and scroll to the bottom, and this test still passed. So once we click delete, the cart array is also correct. So that's how we create an integration test. It tests many units of code or pieces of code working together. And it lets us test how our page looks and how our page behaves. Now, there's one thing that I forgot to do when we created these tests. If we look at our code, and I'm going to open ordersummary.js. When we click delete, at the bottom here, it uses a function called remove from cart. And if I look at the code for this function, which is right here, remove from cart, this function actually saves the cart to local storage and calls local storage.setItem. However, it's recommended not to modify local storage in our tests. So inside the order summary test file, we should also mock local storage.setItem in this test. So we'll scroll to the top. And at the start of the test, let's mock setItem using spy on brackets, local storage, comma, the string set item, and save. And we'll open the test page and make sure that the test still passes. And we might have messed up our local storage because of that mistake. So let's reset the local storage again. We'll right click on this page, inspect, open the console, and we'll type the code local storage.clear brackets and press enter and refresh the page just to be safe. Now, another thing that we might want to add is that when we render the order summary on the page, it's taking up a lot of space and it pushes the test results to the bottom. So what we can do is after our test, we can actually remove all of this HTML. So let's go back to our code. In the order summary test file, at the end of the first test, we'll create some new lines and remove the HTML that we created. To do that, we can scroll up to this code. So to remove the HTML, we can just set this element's inner HTML to the empty string. So we'll select this code, right click, copy, and then down here, right click and paste. So in our test, all the HTML we created was placed inside this test container, and we're just going to remove all that HTML by setting the inner HTML to the empty string. And we'll do the same thing for the second test. So we'll select this code, right click, copy, and then down here at the bottom, we'll right click and paste. So this is just some cleanup we can do at the end of each test. Let's save and look at our test page. And now all the HTML that we generated is gone, and we can see the test results more clearly. Lastly, we're going to learn a shortcut we can use in Jasmine called hooks. A hook lets us run some code for each test. For example, if we go back to our code, notice that before each of our tests, we do a bunch of setup here. So we can actually share all of this code between our two tests using a hook. So to create a hook, we're going to scroll up to outside of both of these tests. And at the top of the test suite, we're going to use another function provided by Jasmine called before capital E each brackets, and we'll give this a function brackets, arrow, and curly brackets. So this is called a before each hook, and it will run this function before each of our tests. So inside this function, we can put our setup code so that we run the setup code before each of our tests. Let's actually take the setup code for the second test because it's a little more detailed. So down here, we're going to select the code starting from render order summary all the way up to mocking local storage.setItem, and we'll right click and cut this code and remove these new lines. And then at the top, inside before each, we're going to right click and paste. So now before each of our tests, it's going to run this function and it's going to run all of our setup code. So this is a great way to share code between our tests and remove duplication. So now that we're running this inside before each, if we scroll down to the first test, we don't have to run this code again. So we can actually remove it. And we'll remove this mock, and we'll remove the render order summary as well. And all we're left with are the expectations for our test. Now, before we save, we need to fix one thing with this code here. So right now, these two variables are inside this function. And because of scope, these will be contained inside this function, and we can't use it down here in our tests. So to fix this, we can just move these variables outside of this function up here. So we're going to select these lines and then right click, cut, and up here, we're going to right click and paste. So now any code inside this outer function can use these two variables, including our tests. So now let's save and check the test page, and everything is still passing. So that's how we use a hook to run some code before each test. Now, before each is not the only hook that we can use. Jasmine provides several hooks that we can use in our tests. Another common hook is after each, which lets us run a function after each test. So this is really useful for cleanup code, like we have down here when we remove the HTML. I'll leave using after each as an exercise. Now let's go into Git and save our changes. And I can close these three files at the top for now. So we'll open the Git section, and then inside ordersummary.js, we added some classes that we're going to use in our tests. Inside tests.html, we are loading our order summary test file, and we also created a test container where we're going to put our HTML that we generate. And then for the order summary test file, this contains the tests that we created for the order summary. Now let's create a message describing our changes. Create automated tests for order summary and commit. Now that we've created all these tests for our project, when we make some changes to our code, we can just open the testing page and it will rerun all of our tests. So here's the process that we do when we write code. First, we make changes to our code, and then we rerun the tests to make sure that everything still works. And finally, we save our changes into Git. Now, before we end the lesson, we're going to do one more cleanup. We'll go back to our code, and we'll open our files. And here, we usually organize all of our tests into a folder called tests. However, in this lesson, we named this folder test-jasmine because we wanted to compare this folder to tests that were created without a testing framework. But now that the lesson's over, we're going to rename test-jasmine to just tests to make it more standard. First, we need to rename this folder up here. So we'll right-click, rename, and let's rename it to test-simple because this folder contains tests that were created without a framework. Let's press enter. And now we can rename test-jasmine to tests by right-clicking, rename, and rename it to tests, and press enter. Another thing we can do is we're going to drag test-simple into the test folder so that all of our tests are contained in one folder. So if it asks you to update the imports, you can click yes. And we also need to open moneytest.js in the test-simple folder because it updated the imports, and then save this file. Finally, we're going to run all of our tests again to make sure everything still works after we move things around. So because tests.html is inside a different folder now, we need to reopen this with live server. So we'll right-click and click Open with Live Server. And it'll show us that all the tests are still passing. So our code is still correct. So now we can close some of these extra tabs here and save our changes into Git. We'll open the Git section. And all of these changes are related to renaming the folders. So we'll give a message at the top, rename test-jasmine folder to tests, and commit. And that's the end of this lesson. In this lesson, we learned how to test our code using manual and automated tests. We learned how to organize our tests using test cases and test suites. We learned how to use a testing framework like Jasmine to help us write tests easier. We learned how to mock and spy on methods. We learned how to test web pages using integration tests. And we learned about hooks, which lets us share code between our tests. Here are some exercises to help you practice what we learned in this lesson. In the rest of this course, if you get an error in your project, but your code looks correct, you may have some bad data saved in local storage. To fix this, you can try running localstorage.clear in your console to remove everything from local storage, and then refresh the page. If you see an error like this, object object, that means that you saved something directly into local storage, but you have to JSON.stringify it first. So check your code to make sure that you're always stringifying before saving to local storage, and then clear your local storage and refresh the page. In this lesson, we're going to learn object-oriented programming. Object-oriented programming, or OOP, is another style of programming. So it's another way that we write our code. It's useful to know because many programming languages use OOP. Now, how do we use object-oriented programming? Object-oriented programming is basically organizing our code into objects. Let's look at an example. We're going to go to our code, and we're going to scroll up and open data/cart.js. Inside this file, we have the code for our cart. And you'll notice that for the cart, we have some data at the top, and then we have a bunch of functions at the bottom that modify the cart. And these are separate from each other, the data and the functions. So this style of programming that we've been using throughout this course is called procedural programming. Procedure means a set of step-by-step instructions. And this is basically a function. So in procedural programming, we organize our code into separate functions like we did here. On the other hand, in object-oriented programming, we organize all of this code into an object. So we put everything together into an object. So let's do an example and convert this cart code into object-oriented programming. We're going to click cart.js, and inside this folder, we're going to create a new file by clicking here. And let's name this file cart-oop, or object-oriented programming.js, and press enter. And now we're going to copy all of the code in cart into this new file. So let's open this, and we'll click in this file, and then we'll type Control A or Command A to select all the code, and then right-click, copy, and inside cart-oop, we're going to right-click and paste. And let's scroll back up to the top. And now to convert this code into object-oriented programming, we're going to group all the data and the functions together into an object. First, at the top, let's create an object that we can put all of these inside of. So we'll create a variable, const, let's call it cart equals an object. And now we're going to group our data and all of our functions into this object. So let's do it step by step, and we'll start with this cart variable. As a reminder, cart semicolon is actually a shortcut for cart equals undefined. To make things easier to understand, let's actually write this out in full instead of using the shortcut. So we'll type cart equals undefined. And now we're going to move this into the object. So we'll select this line, and then right-click, cut, and then inside the object, we're going to right-click and paste. Now, inside an object, we can't use the word export or let. So to move a variable into an object, we're going to convert it into a property and a value. So we'll remove these words, and then type cart and colon undefined, and remove the semicolon and replace it with a comma. So this is the same thing as cart equals undefined, but we move that value into an object. Now, one problem here is that if we access this cart property, we're going to do cart.cart, which can be a bit confusing. So let's actually rename this property to cart capital I items instead, to make it a bit more clear that this contains the items in the cart, or the products that are in the cart. Next, we're going to group all of our functions into this object as well. So let's create some new lines, and we're going to move this function inside here. So let's select this function, and then right-click, cut, and inside the object, we're going to right-click and paste. And again, we can't use the word export inside an object. So we're going to convert this into a property and value as well. So let's remove these words, and let's make the property name load from storage, and then we'll type a colon, and we'll make the value a function, brackets and curly brackets. So that's how we move a function into this object. Now make sure that you use a regular function syntax here and not an arrow function, and I'll explain why later in this lesson. Now, as a reminder, when we have a function inside an object, we call this a method. Also, JavaScript has a shortcut for methods called the shorthand method syntax. So instead of typing colon and function, we can actually just remove this code and just type brackets and curly brackets after the function name. And this is a shortcut for the code that we had before. Now, the code inside this function doesn't actually work anymore because cart was actually renamed to cart items. So we have to rename this variable. So instead of cart, we're going to do cart dot cart items to access this value. And same thing here, cart dot cart items, and here, cart dot cart items. So this code works. However, we have a small problem here. If we change the name of the object up here, this code will no longer work. To solve this problem, JavaScript has a feature called this. This gives us the object that contains this function. So it gives us this outer object up here. So to improve our code, we're going to change from using a variable named cart to this. And here as well, this.cart items and this.cart items. So this will give us the outer object. And now this code will always work, and it doesn't matter what the variable name is. The last thing we're going to change in this function is we're currently loading from local storage cart. However, our original cart was also loading from local storage cart. So let's actually change this to cart-OOP so that we don't affect our original cart. Let's move on, and we're going to move the other functions into this object. So let's go down to the next function, which is save to storage. We're going to select this, and then right-click, cut, and then inside this object, at the end, we're going to add a comma and some new lines, and we're going to right-click and paste. And we can't use the word function at the front here, so let's remove this word and just use the shorthand method syntax. So this is a shortcut for colon function. And here we're saving to local storage cart. So let's also change this to cart-OOP so we don't affect our original cart. So we'll change it to cart-OOP. Another thing we need to change is that the cart was renamed to cart items. So here, we're going to change from cart to this, which gives us the outer object, and then dot cart items, which is this property. So it should do the same thing as before, except this function is now inside an object. Let's continue and move another function into the object. So we're going to do add to cart this time. So let's select this code and then right click, cut, and inside the object, we're going to add a comma and some new lines, and then right click and paste. So again, instead of using export function, we're just going to remove this code and use the shorthand method syntax, which is a shortcut for this code. And now let's update the code inside this function as well. So instead of the cart, we rename this to this.cart items. So we'll change it to this.cart items. And then down here, we're going to change from cart to this.cart items. And also the function save to storage was moved inside the object. So now to access this function, we're going to get the outer object again using this and then dot save to storage. So down here, we'll add this dot in front to access the function inside the object. And now let's move on and move the next function into the object. So we'll select this code and then right click, cut, inside the object, add a comma and some new lines, and right click and paste. We'll remove export function and use the shorthand method syntax. And again, we'll change from cart to this.cart items. We're going to change cart here to this.cart items and change save to storage to this.save to storage. So we access save to storage inside this object. Next, let's move this last function into the object. So we'll select the code and then right click, cut, and inside the object, we're going to type a comma and some new lines, right click and paste. We'll remove export function and use the shorthand method syntax and update the code in this method. So we'll change cart to this.cart items and save to storage to this.save to storage. Now let's remove the extra lines. And the last thing we need to update is that load from storage was moved inside the cart object. So to access this function, at the front, we're going to type cart dot load from storage and save this file. And that's it. This is the basic idea behind object-oriented programming. We organize our code into objects. So we group the data and the functions together into an object like this. Now let's talk about why do we use object-oriented programming. Object-oriented programming tries to represent the real world. In the real world, a cart is a physical object. So in object-oriented programming, we represent this physical object as a digital object, or in this case, a JavaScript object. A physical cart can have products inside. So our JavaScript object can also have products inside. A physical cart also has actions we can take to modify the cart, like we can add a product or remove a product. Our JavaScript object also has actions we can take to modify the cart, like the add to cart function or the remove from cart function. So as you can see, object-oriented programming tries to represent the real world. We take a physical object like a cart and represent it as a digital object like a JavaScript object. And some people feel that this makes the code more intuitive or easier to understand. Now let's try out the code in this object to make sure it actually works. We're going to scroll down to the bottom, and here we're just going to type console.log the cart and save this file. And now let's load this code into the project. To do that, we're going to open the scripts folder and open the file checkout.js. And at the top, below the imports, we're going to import our new file. So let's type import, and we're going to use a slightly different syntax. We're just going to type a string and give it the file that we want to load. So we need to load cart-oop.js. So first, we need to get out of the scripts folder using .. and then go into the data folder, data/ and load cart-oop.js. So this is another syntax we can use for imports. This just runs all the code inside this file without importing anything, which is what we need in this situation. So let's save this file and then open this page in the browser. So if you don't have this page open, you can scroll down to checkout.html and then right-click and open with Live Server. I already have this page open, so I'm just going to open that tab. And if the page is too big, we can zoom out by pressing Ctrl- or Command- a few times. And now let's check the console to see what the cart looks like. On this page, we're going to right-click and click Inspect, and then open the console. And in the console, we'll see this cart object. So inside this object, we have the data as well as all the functions for our cart, but it's grouped inside an object. And you'll see that the code still works the same as before. Cart items has the two default products. If we look at our code and open cart-oop, at the beginning, we run cart.load from storage. And then inside this function, if we scroll up, it will give the cart items this default cart with two products inside. And that's what we see in the console here. So we know that the code inside this object still works the same way as before. So now let's try another method to make sure that it's working. So let's try using the add to cart method to add a product to the cart items up here. So we'll scroll down to the bottom, and then above console.log cart, we're going to call add to cart. Now add to cart was saved inside this cart object. So to access it, we're going to type cart.add to cart and brackets. Now add to cart takes one parameter, which is a string, and this is the product ID that we want to add. So to find a product ID, we can go to the data folder and products.js. And then inside here, we have this list of products. So let's actually scroll down to the third product, which is right here. So this t-shirt product. And we're going to add this product ID to the cart. So let's select this ID. We're going to right-click, copy, and then inside cart-oop, inside the string, we're going to right-click and paste that product ID. And let's save. And let's check the console. So I'll open the console here. And now inside the cart object, if we expand it, cart items now has 3 products because we just added a new product to the cart. So this shows that all of the code is working the exact same way as before. We just organized it into an object. And that's object-oriented programming. Now that we're done with this example, let's remove these 2 lines of code and save. Next, another reason we use object-oriented programming is it's easy to create multiple objects. For example, the real Amazon.com has a feature called Amazon Business, where you can have a separate cart for your business purchases. So how do we create two separate carts in our code? With object-oriented programming, this is easy. We can just make a copy of the cart object. So we can scroll up in this code, and I'm just going to click this arrow here beside the cart variable to collapse this code. And to create a separate cart for business purchases, we're just going to select this code and then right-click, copy, and at the bottom, right-click and paste. And now we have two separate carts. So let's scroll up to the top of this second cart, which is right here. And we said that we wanted this cart for business purchases. So let's rename this to business, capital C, cart. And when we load from storage, let's load it from cart-business instead, so that it doesn't conflict with the cart up here. And if we scroll down, same thing in save to storage. Let's save this cart to cart-business. And finally, let's scroll down to the bottom. And here, instead of cart.load from storage, we're going to change this to business cart.load from storage. And that's it. We just created a completely separate cart simply by copying this object. So object-oriented programming makes it easy to create multiple objects. So now let's console.log both of these carts to see what they look like. We're going to scroll to the bottom, and here we're going to console.log the cart and console.log the business cart and save. And if we open the console for the checkout page, it will show us that we have two carts. The regular cart has 3 products inside, and the business cart has 2 products inside. And these are just the default products that we get when we first load the cart. So you can see that these two carts are completely separate from each other. In the real world, we can have 2 physical carts that are completely separate from each other. And in programming, we can also have 2 carts that are completely separate from each other by simply making a copy of the object. So again, object-oriented programming tries to represent the real world. Now, currently, there's an obvious problem with how we're creating multiple objects, which is we're copy-pasting a lot of code. And this can make our code messy and hard to manage. So now we're going to make our code cleaner by using a function to create multiple objects. So first, let's delete this business card that we copy-pasted. So we're going to select this object. And then up to here, the business card, we're going to remove it. And now instead of copy-pasting this object, we're going to use a function to generate these objects. So at the top of this file, let's create a new function. And we'll name it capital C cart, brackets and curly brackets. So by the way, in object-oriented programming, a naming convention is to use Pascal case for things that create or generate objects. In Pascal case, we start every word with a capital, including the first word. So that's why we started cart with a capital C. Now inside this function, we're going to create cart objects. So let's actually move this object into the function so we can create it using the function. So we're going to select this object to here, and then we'll right-click and cut, and then move it into the function by clicking in the function and then right-click and paste. So now every time we run this function, it will generate a new cart object. And we don't have to copy paste this code over and over to create multiple objects. So at the bottom, I'm going to click this arrow to collapse this object for now. And at the bottom of this function, we're going to return this cart object so we can use it outside the function. Okay, now let's give this a try, and we'll use this function to generate cart objects. So first, let's create the normal cart using const cart, make it equal, and we'll run this function to generate an object. Capital C cart and brackets. And let's generate another object using the function using const, and we'll name it business cart equals capital C cart and brackets. And we'll still load from storage for both of these and then console log both of these. So basically, instead of copy pasting all the time, we're going to use a function to generate objects. So now let's save and then open the console. And now we have two cart objects again. However, now both of these carts have 3 products inside. But before, the regular cart had 3 products and the business cart had 2 products. So what happened? If we go back to our code and look inside this cart object, you'll notice that we're loading from the same key in local storage, which is cart-OOP. That means every cart that we generate will be getting its data from the same place in local storage. So to fix this, we're going to replace cart-OOP with a parameter, so different carts can use a different key in local storage. So at the top, let's create a parameter called local storage key. And then instead of using the same string every time, we're going to use the parameter local storage key. And the same thing for save to storage. Instead of saving to the same key every time, we're going to replace this with the parameter local storage key. And finally, when we run this function at the bottom here, we need to give the function a local storage key. So for our regular cart, let's use the string cart-OOP. And for the business cart, we can use a different key, like the string cart-business. So now these 2 carts will load from different keys in local storage, and they can have different data. So let's save and then check the console. And now our regular cart has 3 products and our business cart has 2 products like before. So let's go back to our code. And this is a better way to create multiple objects. Instead of copy pasting a bunch of code every time, we can create a function that generates objects. So now let's save this example into Git. We'll go into our Git section. And then at the top here, we created a function to generate these objects. And in checkout.js, we are loading that cart-OOP practice file. So we'll type a message to describe these changes. Create OOP, or object-oriented programming, version of cart, and commit. Next, we're going to learn an even better way to generate objects. Object-oriented programming has a feature called a class. A class is specifically designed for generating objects. A class is basically an object generator. So currently, if we open our code and then open cart-OOP, we learn how to use a function to generate objects in object-oriented programming. So now we're going to switch this to using a class to generate these objects instead, because classes are cleaner and have more features than using a function. So first, let's create a new file for learning classes. Inside the data folder, we're going to click cart-OOP and then create a new file. And we'll name this file cart-class.js and press enter. So first, let's copy over all the code so we can compare it. We're going to open cart-OOP, click this file, and then press Ctrl A or Command A to select the code and right-click, copy, and in cart-class, we're going to right-click and paste. And we'll scroll to the top, and at the top, we're going to create our first class using the word class. And now we're going to give a name to this class. So let's name it the same as here. Capital C, cart, and then curly brackets. As a reminder, a naming convention is to use Pascal case for things that generate objects. So that's why we start this cart with a capital C. So this is a class. A class is basically an object generator. So now inside the class, we're going to put the properties and methods that we want for each object that we generate. So here we have our properties and methods. We're just going to move them into the class. So first, let's select the cart items property. We're going to right-click, cut, and then move it into the class by clicking in here and then right-click and paste. And classes use a slightly different syntax than objects. So to create a property called cart items, we're going to type the property name, and instead of a colon, we're just going to make it equal to undefined. And instead of a comma at the end, we're going to put a semicolon. So that's how we add a property to a class. And now every object that we generate will have this property, just like we did before. Next, let's move the methods into the class. So we'll delete these lines for now, and we'll move load from storage. So we'll select this method, and then right-click and cut. And inside the class, we're going to move it by right-clicking and paste. And classes use a slightly different syntax to create methods as well. So instead of having a comma at the end, we can just remove it. And every object that we generate will now have this method. So now let's move the rest of the methods into this class. We're going to scroll down and we'll move save to storage. So we'll select the method and right-click, cut, and at the bottom of the class, we're going to right-click and paste, and remove the comma at the end. Same with add to cart. We'll select this method, and then right-click, cut, and inside the bottom of the class, we're going to right-click and paste, and remove the comma at the end, as well as remove from cart. So we'll select this method, right-click, cut, and at the bottom of the class, right-click and paste, and remove the comma at the end. And finally, we'll move the last method, update delivery option, and right-click, cut. Inside this class, we're going to right-click and paste. So this method did not have a comma at the end, so this looks good. So that's how we create a class. We basically give it some properties and methods, and now when we generate objects using this class, every object that we generate will have these properties and methods. Now, one thing we need to fix here is that local storage key doesn't exist anymore. To fix this, we're going to save this in a property instead. So at the top, we're going to give a new property to every object that we generate called local storage key and make it equal to undefined to start. And then inside the methods, we're going to switch this to this dot local storage key. So this is going to point to the object that we generate, just like before. And then dot local storage key will access this property. And another place we need to fix this is inside save to storage. So instead of using a variable local storage key, we're going to use the property this dot local storage key. And that's it. So if we scroll down, we basically converted this whole function into a class. So now we can remove it. And the final step here is now that we have this class, let's use it to generate these two objects again. To do that, instead of this code, we're going to type the word new, and then type the class name, which is capital C cart, and brackets. So you see that a class uses a similar syntax as a function, except we use the word new in front of it. So this generates a new object using our class. And this new object will have all the properties and methods that we added above. So let's do the same thing for the business card. We'll use the class to generate it. We'll remove this code, and then we'll type new and the class name capital C cart and brackets to generate another object using this class. Now there's one thing we need to fix here. Each of these objects has a property called local storage key, and they're currently undefined, so we need to set this property. So at the bottom here, we're going to type cart dot local storage key, and we'll make it equal, and we'll use the same string as before, which is cart-OOP. And we'll do the same thing for the business cart. We'll type the business cart dot local storage key and make it equal the same string that we had before, which is cart-business. And then we'll load the cart from storage as well as the business cart from storage, and we'll console.log them. So we have the same code as before, except we converted it from a function to a class. So now let's save, and we're going to run this code. So currently, if we go into our code and open checkout.js, we're still loading cart-OOP. So we're just going to update this and load cart-class instead, and save. And we'll open cart-class again. And now if we open the console, you can see that we created two cart objects just like we did before. And the regular cart has 3 products inside, and the business cart has 2 products inside. And if we click this arrow beside prototype, we can see the methods that each of these objects has. So we're basically creating the same objects that we had before, except this time we used a class. By the way, each object that we generate from a class is called an instance of the class. We can also check if an object is an instance of a class using the code business cart and then instance of and then the class name capital C cart. So this will check if this object was generated from this class. So we can console.log this result, console.log, and close bracket, and save, and then check the console, and it will tell us that this is true. So business cart was generated from this class. Okay, don't worry if classes are a bit confusing at first. Just remember that object-oriented programming means organizing our code into objects. because this tries to represent the real world. And then classes are a feature that help us generate these objects. So they make it easier to create these objects. A class is basically an object generator. Now that we learned how classes work, let's talk about the benefits of classes. If we scroll up, when we generate an object, it's going to have these properties and these methods. And you'll notice that a class actually looks like the object that we generate. And this is cleaner than using a function like we had before. Another benefit of classes is that they have extra features for object-oriented programming. The first feature is called a constructor, which lets us run some setup code after creating an object. So if we scroll down in our code, you'll notice that after we create these objects, we run some setup code. A constructor lets us put this setup code inside the class. And this makes our code cleaner because we can group everything together inside the class. To create a constructor, we're going to scroll up in the class. And below these properties, we're going to create a new method called constructor. Brackets and curly brackets. So the constructor method works like a normal method. We can put code inside and it will run the code. But the special thing about the constructor is that when we generate an object, it will run this constructor automatically. So this is a great place to put our setup code. So let's scroll down to the bottom. And here, instead of running the setup code outside the class, we're just going to move this into the class and into the constructor. So we'll select this code and then right-click, cut, and scroll to the top. And inside the constructor, we're going to right-click and paste. So now, after we create an object, it will run the code in the constructor and set up the object. So there's a few things that we need to fix here. The first thing is each object that we create is going to run the constructor. So we only need one of each of these lines. So let's remove the setup for the business card. So now the setup code has two steps. We set the local storage key, and then we load from storage. The next problem is that the object that we create is not going to be called cart every time. To solve this, we can replace cart with this. And here as well, this.load from storage. So as a reminder, this points to the object that we generate. So whatever object that we generate, we're going to get its local storage key and set it, and we're going to get its load from storage method and run that method. Now the second problem here is that we don't want local storage key to be cart-OOP every time. To fix this, the constructor can also have parameters. Let's give the constructor a parameter, and we'll name it local storage key. And instead of the same string every time, we're going to use local storage key. Now the last thing is, how do we save a value into this parameter? So if we scroll down to the bottom, when we call the class, between these brackets, we can put the parameters for the constructor. So for the cart, we want the local storage key to be the string cart-OOP. And for the business cart, we want the local storage key to be the string cart-business. So the values inside here are saved in the parameters in the constructor. So cart-OOP will be saved inside local storage key and then we use it. And then the same thing for cart-business. So now let's save this code and then open the console. And you'll see that the cart objects are correct. So after we generated each object, we also ran this setup code. So that's how the constructor works. Every time we generate an object, it will run the code inside here. So this is a great place to put setup code and make our code cleaner. So here are a few more details about the constructor. The method has to be named constructor. We can't just use any name that we want. We also should not return anything from a constructor. So lastly, a shortcut that we can use in a class is when we have a property and it's equal undefined, we can actually remove equal undefined and just use a semicolon. So this is the same thing as the code before. And same thing here. We can remove equal undefined and just use a semicolon and save. So we finished converting our code from using a function to using a class. And as you can see, a class is just a better way to generate objects in object-oriented programming. So now let's save our code into Git. We'll open the Git section. Inside cart-class, we created our cart class. And inside checkout.js, we're basically loading the cart-class file. So we'll type a message to describe this change. Create class version of cart and commit. Next, we're going to learn an important feature of classes called private properties and methods. So let's open our code again and open cart-class. And you'll see that this class has a property called local storage key. So this property is useful inside the class, but it's not really meant to be used outside the class. For example, at the bottom here, we could take this object, cart, and then change the local storage key using .local storage key equals something else. Now, this is a problem because it will mess up how this object works, and it will start saving to a different local storage key. So this is a common problem in programming, where if you're working on a team, somebody might accidentally change properties that they're not supposed to. To prevent this, classes let us make a property or a method private, which means it can only be accessed inside the class. So let's remove this line and scroll up. And to make local storage key private, we're just going to add a number sign in front, or a hash. And also, whenever we access this property inside the class, we're going to add the hash in front. So we'll type this .hash local storage key, this .hash local storage key, and inside save to storage, this .hash local storage key. So this is called a private property. This means it can only be used inside this class or inside these curly brackets. It cannot be used outside the class. A property without a hash in front is called a public property, meaning it can be accessed anywhere. So now let's save and open the console. And the code still works. So we made this property private, and we're able to access it inside the class. So now let's try accessing this property outside the class to see what happens. We're going to scroll down, and we're going to try to access cart.hash local storage key and change it to something else, like test, and save. And if we open our console, you'll see that when we try to access a private property here, it will give us a syntax error saying this is a private field. And by the way, a field is the same thing as a property. So that's how a private property works. It prevents us from accessing this property outside the object and messing it up. We can also have private methods. So let's remove this line and scroll up. And the method load from storage should also only be used inside this class. There's really no reason for code outside to be calling load from storage. So to make our code safer, we're going to make this a private method. To make a method private, we're going to do the same thing. In front of the method, we're going to add a number sign or a hash. And we're going to update the rest of our code. So we're going to do this dot hash load from storage. And now we can save and check the console to make sure that everything is still working. So everything still looks good because we're only using this private method inside this class. So a class lets us create private properties and methods. And this is useful on a bigger project where people might not be sure which properties and methods they're supposed to use outside the class and which ones to avoid. So now let's save our changes into Git. We'll go into the Git section. And inside here, we made local storage key and load from storage private. We'll create a message to describe these changes. Make local storage key and load from storage private and commit. Now that we learned object-oriented programming and classes, we're going to use it in our project. So one thing we could do is to take this cart class and replace everywhere we use cart in our project. However, we use cart in a lot of places, and this would take too much time. So I'm going to leave replacing the cart as a challenge exercise. Instead, we're going to work on the home page. So first, let's go back to our code, and we're going to open checkout.js, and we're just going to comment out this import because we're just using this file for practice. So let's save this, and then let's open the checkout page. So I already have it open. If you don't have it open, you can right-click checkout.html and open with live server. On the checkout page, we're going to click this icon in the top left to go to the home page. On this page, we have a list of products here. And the code for these products is if we go back to VS Code, and on the left side, we're going to open data/products.js. So here is the code or the data for all the products on the homepage. And you'll notice that each product is an object. We're going to learn a technique called converting an object into a class. So what this means is, instead of using regular objects in this array, we're going to use a class to generate these objects. So above this array, let's create a new class using the word class, and let's call it capital P product and curly brackets, because this class is meant to generate products. So now each of our products is going to have some properties like the ID, image, and the name. So let's add these to the class. We'll add the ID property and a semicolon so that it starts off as undefined, and then an image property and a name property. And each product will also have a rating and the price cents. Rating and price cents. And you'll notice each object here also has a property called keywords. Now we're not currently using this in our project, so we're going to leave it out of the class for now. And if we need to use it later, we can always add it back in. So now we have all the properties that we want for each product. So now let's test this by generating a product using this class. So down here, let's create a variable const product1 equals, and to generate an object, we're going to use the word new, and then the class name, capital P product, and brackets. And let's console.log this to see if it worked. Console.log product1 and save. So now we're going to open the web page and then open the console. So right click and inspect and open the console. And inside here, you'll see that we created a product object using the class. So right now, all of these properties are undefined. So now let's set the values of these properties. We'll go back to our code. Don't follow along here, but one way to set these properties is to access them outside the class. For example, product1.id equals something, and then do product1.image equals something, and then product1.name, and so on. So this is not a good way to set these properties because we have to do this for each product that we create, so it makes our code repetitive and messy. Instead, notice that when we create a product, this is kind of like the setup code. We create a product and then set all of its properties. And remember, classes have a specific feature for setup code called the constructor. And now you can follow along. So inside this class, we're going to create a constructor, brackets and curly brackets. So whenever we generate an object, it's going to automatically run this constructor. So this constructor is where we should put our setup code. So let's remove this code and then do all of that inside the constructor. So first, we want to set the ID property. We're going to do this.id and make it equal. And now what value do we set the ID to? So the value of the ID is inside each of these objects. So when we create a product up here, we're going to put this object inside these brackets. And then that's going to go into the constructor in here. So in the constructor, let's create a parameter to save this data. So we'll name it product details. And now to save something inside this parameter, we're going to put it between these brackets. So let's actually give this entire object to the constructor. So we're going to right click and copy. And then between these brackets, we're going to right click and paste. So whenever we create a new product, we're going to give it this object with all the details. It's going to get saved in here. And now we can set the properties. So this.id is going to be equal to the product details.id property. So product details.id. And for the image, we're going to do this.image equals the product details, which is this object that we passed in, dot the image property. Same thing for the name. So this dot name equals product details dot name, which is this property here. Same thing for the rating. This dot rating equals product details dot rating. And finally, the price cents. This dot price cents equals the product details dot price cents. So this is called converting an object into a class. What we're doing is we're basically taking a regular object like this, we put it inside a class, and then we copy over the properties. You can also visualize it like this. We have a regular object, and we're basically wrapping it inside a class. And the reason we do this is that classes have extra features we can use. Like we can add methods, and we can also have private properties and private methods. So we basically have the same object as before, except we have an enhanced version of that object. It has some extra features from classes. So for now, let's save this code. And then down here, we console.log product1. So let's take a look at it in our console. So we'll open the console. And now we can see that we created a product object. So it's the same object as before, except now it's enhanced. It has some extra features from classes. So next, we're going to take this technique and apply it to this entire array. So instead of having an array of regular objects, we're going to convert each of these objects into the product class. Now, one way we could do this is that in front of the object, we can just type new product, open bracket, and then close bracket at the bottom. And this will essentially convert this regular object into the product class. However, we're going to have to repeat this code for every object in the array, and it's going to be a lot of work and repetition. So instead, let's just loop through this array and then use code to convert each of these objects. So instead of typing this out manually, we're going to remove this and remove the round bracket at the end. And then I'm going to click this arrow beside the array to collapse it. And at the end of the array, we're going to use an array method called .map and brackets. So map basically loops through an array, and for each value, it runs a function. So we're going to give this a function that we want to run for each value. So arrow and curly brackets. And this inner function is going to get a parameter. So this parameter is basically each value in the array. So it's going to take the first value and then save it inside this parameter, run the function, and then take the second value, save it in here, run the function, third value, save it, and run the function. So let's name this parameter the product details, because each object in this array contains product details. So now it's going to take each object, save it in the parameter, and run the function. And here, we're going to convert the object into a class. To do that, we're going to use the code new capital P product brackets, and we're going to give it this regular object, which is the product details. And now there's a second part to how map works. So .map creates a new array, and whatever we return from this inner function is going to go inside that new array. So here, we're going to return this class. So this result is going to be put inside a new array. So you can think of map as we take each value in an array, we run this function on it, and we transform it, and then put it inside a new array. So here, we're essentially transforming each of these products or these regular objects into a class. So at the bottom, let's console.log the products array to confirm this. So we'll save and open the console. And now you can see we have an array, and each of the values is a product class instead of just a regular object. So we converted all of our products from regular objects into this product class. And now let's open the web page to make sure that everything still works. So if we open the page, you'll notice that everything is still working correctly. And that's because we have the exact same objects as before, except they're now just sort of enhanced objects. Next, let's use those extra features of classes to simplify our code for this page. We'll go back to our code, and on the left side, let's open amazon.js. So this is the code that creates the home page. So in here, we're going to scroll down until we see the rating section, where we calculate the stars and the rating count. So notice that inside our HTML, we're constructing this URL here for the number of stars a product has, and we're also creating the price that we want to display on the page. Now, instead of doing this all in the HTML, our code would be cleaner if we moved this logic into our class, because we want to group this related code together. So let's use the features of classes to make this code a little bit cleaner. We'll open products.js, and we'll scroll up to the product class. And inside here, let's add some methods for calculating the stars and the price. So we're going to add a method and call it get stars URL brackets and curly brackets. And let's create another method called get price brackets and curly brackets. And now we're going to move the code from our HTML into this class. So we'll open amazon.js. And then here, we're creating the URL of the stars. So let's actually select all this code and right-click, copy, and inside products.js, inside get stars URL, we're going to right-click and paste. And this is going to be a string. So at the front, let's add a backtick. So we're going to use a template string because we're going to insert a value inside. And at the end, we'll add another backtick. So now that we created the string, we're going to return it from this method. So return and semicolon at the end. And one thing we need to fix is that product is not defined anywhere. So to get the rating property of whatever object this is, we're going to use this .ratings.stars. So now each product is able to construct its own stars URL here. So let's save this file. And then inside amazon.js, instead of doing this calculation directly inside the HTML, we're going to delete it and we're going to insert the product.get stars URL method and brackets. So you'll notice that we have the same product object as before, but now it's sort of an enhanced product. We can add methods to group related code together and make our code cleaner. Let's do the same thing with the price down here. We're going to calculate this using the method instead of directly in the HTML. So we're going to select this code and then right-click, copy, inside products.js, inside the getPrice method, we're going to right-click and paste. And again, we want to return the price as a string. So at the front, we'll create a template string because we're inserting a value, and at the back, a template string or a backtick. And we're going to return this from the method. And another thing we need to fix is that product is undefined. So to get the price sense property, we're going to use this .price sense. Now, one extra thing we need to do here is that we're using the format currency function, but we didn't import it. So we're going to scroll to the top and import format currency. Import curly brackets the format currency function from a string. And here we're going to locate this function. So we're inside the data folder. We need to get out of the data folder using .. and then go into the scripts folder, into the utils folder, and load money.js. So scripts/utils/money.js, and save this file. So now we have two methods that will simplify our code. We'll open amazon.js, and instead of calculating the price inside the HTML, we're going to remove this and then insert the product.getPrice method and brackets. So now let's save, and let's open the home page to make sure that it's working. So now you see that everything is still working, including the stars and the prices. So we'll go back to our code. And now that we have these methods, let's use them in our other page, which is the checkout page. So we'll open scripts/checkout/order-summary.js. And this basically displays the products on the checkout page. If we scroll to the HTML and find the delivery date, the product image, and the product name, we're going to see that here we're also calculating the product's price directly in the HTML. So instead of doing this, let's use the method we just created. So we'll select this code and remove it and insert the matching product this time. So matching product. And remember, we converted all of our products into classes. So this is not a regular object anymore. It's more of an enhanced object. It's a product class. And that means this will have the method .getPrice and brackets and save. So now let's open the checkout page to see if this works. We'll open the web page, and then at the top right, we're going to click the cart. And now you can see that on the checkout page, the price is still displayed correctly. And that's it. If we go back to our code, you'll see that by converting our objects into classes, we're able to use extra features of classes, like methods, to make our code cleaner. So now let's make sure that all of our tests are passing. We'll go to the left and scroll down, and we're going to open test.html in the browser. So if you don't have it open, you can right-click and open with live server. But for me, I already have it open. So I'm going to open the test page, and all of our tests are still passing. So our code is still correct. And now let's save our changes into Git. We'll open the Git section, and in products.js, we created the products class, and at the bottom, we converted all of our objects into the products class. So actually, one thing I forgot to do is to clean up these console.logs. So let's do that right now. We're going to open our code and go into products.js. And we'll scroll down right after the product class. And let's remove this product1 because it was just an example. And we'll also remove the console.log products at the end. And save. So now if we go back into Git and open products.js, we just have the code where we convert our objects into a class. In amazon.js, we use the feature of classes called methods to make our code cleaner. In checkout.js, we stop loading our cart class practice file. And in order-summary.js, we also used a method to make our code cleaner. So now let's create a message to describe these changes. Convert products into classes and commit. Next, we're going to learn an important feature of object-oriented programming called inheritance. Inheritance lets us reuse code between classes. So first, let's learn the concept of inheritance. To do that, we're going to open our project. So we'll open this page here to our checkout page, and we're going to go to the home page by clicking the top left. And on this page, we have a bunch of products. But you also notice that we have different types of products. For example, we have clothing like this t-shirt, and we have appliances like this toaster. So clothing and appliances are still products. They have a name, a price, and a rating, but they are a more specific type of product. For example, clothing can have all the properties of a regular product, but it can also have specific properties like a size chart. So how do we represent this kind of relationship in our code? We have a product, and then we have a more specific type of product. One way to represent this is to create a new class called clothing. And this class will have all the properties of a regular product, but also more specific properties. However, there's a problem with this, which is we're duplicating a lot of code. Instead, object-oriented programming has a feature called inheritance that allows one class to get all the properties and methods from another class, so we don't have to copy-paste this code. For example, we can make a clothing class and then use inheritance to get all the properties and methods from the product class. This is similar to how a child inherits things from their parents, like their hair color or the shape of their eyes. In fact, we call the product class the parent class, and we call the clothing class the child class. So now let's learn how to use inheritance in our code. We're going to open VS Code and open our code on the left, and then open products.js. And we're going to scroll to the product class, and then below this class, we're going to create a more specific type of product called class and capital C clothing and curly brackets. So we said that clothing is just a specific type of product. So that means clothing should have all the properties and methods of a product. So first, let's inherit all these properties and methods into the clothing class. To use inheritance, after the class name, we're going to use the word extends. And then we're going to give it the class that we want to inherit from, which is the product class above. So this means that clothing will get all the properties and methods of this class, or it will inherit all the properties and methods. To demonstrate this, let's leave this empty and create a new clothing object. So down here, let's create a variable first using const, and we'll name it a t-shirt. Make it equal, and we'll generate a new clothing object. To do that, we'll use the word new, capital C clothing, and brackets. And next, we're going to expand the products array, and we're going to give the product details to this class. So we're going to scroll down to the third product, which is the t-shirt. And we're going to select this object and then right-click, copy, and scroll up. And now between these brackets, we're going to right-click and paste. So now we created a new clothing class. We gave it all the data that it needs. And let's console.log it to see what it looks like. So down here, we're going to console.log brackets and the variable name, which is t-shirt. So here, t-shirt, and save. And now let's open the console. So we'll open our web page, and then on this page, we're going to right click, inspect, and open the console. And you'll see that we created a new clothing object. And if we open it, you'll see that this has the same properties as the product class. So this inherited all the properties from product. So let's see if we inherited the methods as well. We'll go to our code, and let's try the method getPrice. So we'll console.log t-shirt.getPrice and brackets and save. And now if we open the console again, you'll see that getPrice also works. So clothing inherited the methods from product as well. So even though this is empty, this class gets or inherits all the properties and methods of product. So we use inheritance when we have one class which is a more specific type of another class. For example, clothing is a more specific type of product. We want all the properties and methods of the product still, but we just don't want to copy paste all this code down here. So inheritance lets us reuse code between classes. So now that we have this clothing class, we can add properties and methods that are more specific to clothing. For example, clothing can have a size chart. So for convenience, inside this t-shirt object, I've actually added a size chart link. So let's add this to our clothing class. So up here, we're going to add a property, size chart link. And now to set this value, we're going to use the constructor like we did before. So down here, we're going to use a constructor, brackets and curly brackets. And we're going to give this a parameter called product details. So when we create the clothing, we save this object into product details, and then we can use it to set the properties up here. So we're going to do this dot size chart link and make it equal to the product details, which is this object, and we're going to get the size chart link property. Dot size chart link. Now, one problem we have here is that clothing inherits all the properties from the product. So we also need to set the ID, the image, the name, and so on. So if we scroll down, we could do something like this.id equals productdetails.id. However, instead of doing this one by one all over again, inheritance gives us a shortcut. We can actually just use the constructor in the parent class up here. So to call the parents constructor, we're going to use a special feature of classes called super and brackets. So super basically calls the constructor of the parent class, which is the product. So this will call the constructor up here. And we also need to give this the product details. So down here, we're going to call super and give it the product details. So this will call the constructor of the parent class, which is product, and that will set the ID, the name, and the rating. So now let's save this and check our console again and open up the clothing object, and you'll see that now we have a size chart link property. So that's how inheritance works. A class can get or inherit all the properties and methods of another class and reuse that code. And this class can also have more specific properties and methods, like a size chart link. One last thing to know is that if we don't create a constructor, By default, it will run the parents constructor. So that's why when this class was empty, the code still worked. Now that we have this clothing class, we're going to use it in our project. So right now, if we scroll down to our products array, we converted all of these into a product class. However, we're going to convert some of them, like the t-shirt, into a clothing class instead to make it more specific. So how do we know which objects to convert into a product and which ones to convert into clothing? To help us do that, I included a property called type. So type tells us which class we should use when we're converting this into a class. This is sometimes called a discriminator property. It tells us which class we should convert this to. So we're going to go down to the bottom of this code. So I'm going to do a trick here where I'm going to scroll up to the products array and click this arrow to collapse it. And then at the bottom, we're going to use that type property to decide which class to use. So inside this function, we're going to use an if statement, brackets and curly brackets. And inside, we're going to check the type property, product details dot type. And we'll check if it is equal to the string clothing. If it is equal to clothing, we're going to convert this object into a clothing class instead. So let's return new capital C clothing and brackets. And we're going to give the constructor product details. So now our array will contain a mix of regular products and clothing. Next, for each of our clothing, we're going to display the size chart link on the page. But first, let's make sure that we have this image here, the clothing size chart. So if we go into our images folder, you might see the image here called clothing size chart.png, but currently I don't have this, so I need to download this first. To do that, we're going to click this link in the description, which will open the size chart. And then on this image, we're going to right click, save image as, and then find the folder that contains all our code. So for me, it's on the desktop, inside the JavaScript Amazon project, and inside the images folder. And we'll save it here. And if we go back to our code, we should have the closing size chart image inside the images folder. Now let's display the size chart on the page. So if I go to the home page, whenever we have a clothing product like this t-shirt, we're going to display a size chart underneath. Let's go back to our code and open amazon.js, which creates the home page, which is right here. And we're going to scroll down the HTML below the product price and the quantity selector here. And underneath this, if we have a clothing product, we're going to display a size chart link under the quantity selector like this. So one way we can do this is to use something like an if statement or a ternary like this. If it's a clothing, then display some HTML. If it's not a clothing, then just display nothing. However, we're going to learn a different way to do this using inheritance. So first, we're going to create a new method on the clothing class that's going to generate the HTML that we need here. So we're going to go to our code and scroll up and open products.js. And we're going to scroll up to the clothing class. And at the bottom, we're going to create a new method And let's call it extra info HTML, brackets and curly brackets. So this method will generate some HTML that contains some extra information about this product, like the size chart. So here, we're going to return some HTML, and we'll use a template string because we're going to insert some values inside. And inside here, let's create some HTML for a link. To create a link, we're going to use the code less than a greater than less than slash a greater than. So this HTML element creates a link. When we click this link, it will open another page. Inside this link, let's put the text size chart. So this is what's going to show up on the page. And link elements have two attributes. The first attribute is called href equals double quotes. So this tells the computer which page this should open when we click this link. Inside here, we're going to insert the size chart link. So we're going to insert this dot size chart link. So when we click this, it will open a page containing the size chart image. We'll scroll back up. And link elements can have another attribute called target equals double quotes. And we're going to give it a value of underscore blank. And I'll add some new lines here to make it a little easier to read. So target equals blank tells the link to open in a new tab. So now let's save this file and we'll go back to the home page. So I'll scroll down here to amazon.js, and below the quantity selector, let's insert, and we'll call the method that we just created, which is the product.extra info HTML and brackets. So this will insert some HTML containing extra information about the product, like the size chart. Now, before we run this code, there's one thing that we need to fix. Currently, only the clothing class has this method. If it's just a regular product, it's not going to have this method and it's going to cause an error. To fix this, we're also going to create this method on the product class. So we'll go back to our code and open products.js. And we're going to scroll up to the products class here. And at the bottom, we're going to add the same method. Extra info HTML, brackets and curly brackets. And for regular products, we don't have any extra info we want to display. So let's just return an empty string and save. So now if we call extra info HTML, it doesn't matter if it's a product or a clothing. Both of these will have this method defined. So we'll go back to amazon.js. And now this should always work. So let's click this file and save. And then open the web page to see the result. So now you notice that products that are clothing have a size chart underneath, and regular products don't have any extra information. And if we click the size chart link, it will open a new tab to the size chart image. So that's how we create this size chart link for only the clothing products. Let's go back to our code and we'll learn more about this new technique that we just used. So on the left, we'll go back to products.js first. So notice that the product class has a method called extraInfoHTML, and then clothing extends this class. That means clothing will automatically get the extra info HTML method. But then we define this method again inside clothing. So this will actually override or replace the parent's method. And this technique is called method overriding. One more thing to know about method overriding is that if we really need access to the parent's method, there's a feature that we can use called super. So super gives us access to the parent class. So if we want to call this method up here, we can do super and then dot extra info HTML. So it's the same super as we used up here, except this calls the parent's constructor and this calls one of the parent's methods. So let's comment this out since it's just an example. And let's save. And lastly, let's go back to amazon.js and we'll take a look at this code and notice that when we call extra info HTML, we don't know what class this is. This might be a clothing class or it might just be a product class. This technique is called polymorphism, which means we can use a method without needing to know exactly what class this is. Polymorphism is sort of like an alternative to doing if statements here. Instead of doing if it's clothing, do this, if it's a regular product, do something else, we can just have both of the classes use the same method, and then the class itself will determine what this method does. If we add a new class, like an appliance class, we don't need to change any of this code. The appliance class will determine what extra info HTML does. And that's it. We learned about inheritance, which lets us reuse code between classes, and we learned some of the techniques we can do with inheritance, like method overriding and polymorphism, which can make our code a little bit cleaner. Now let's check our test to make sure that everything still works. So we'll open the test page and make sure that everything is still passing. And then we'll go back to our code and we'll save this into Git. Open the Git section and in products.js, we created the clothing class, which inherits from product. And one thing I forgot to do is to remove this practice code. So let's actually go back to our code in products.js. And below the clothing, let's remove this practice code and save. We'll go back to Git and just make sure that it's been removed. And then we added the size chart image. And in amazon.js, we used polymorphism to add some extra info below each product. So let's create a message describing our changes. Use inheritance and polymorphism to add size chart and commit. In the rest of this lesson, we're going to learn more details about classes. The first detail is how to test classes. So testing classes is the same as writing normal tests. So we generate an object using a class, and then we test if its properties and methods are correct. I'll leave writing tests as an exercise at the end of this lesson. The second detail we're going to learn is built-in classes. These are classes that are provided by the language. So let's go back to our code and open products.js again. And we're going to practice using a built-in class. An example of a built-in class is date. This class generates an object that represents the current date. Below the classes that we created, we're going to create some new lines and we're going to practice using the built-in date class. First, we'll generate a new date object using the code new, and then the class capital D, date, and brackets. And now let's save this object in a variable. So at the front, we'll use const, and we'll call it date, and make it equal to this object that we just generated. And below this, let's console.log the date to see what it looks like. So we'll save, and then open the page, and we'll go back to our project here, and we're going to check the console. So right click, inspect, and the console. And we can see that the date object represents the current date and time. So this is the current date and time that I'm recording this video. So this date object has properties and methods that we can use that are related to the date. For example, we'll go back to our code, and every date object has a method called toLocaleTimeString. This basically gives us the current time. So let's try it out. We'll create a new line and type the code date dot toLocaleTimeString and brackets. So make sure that this is in camel case. 2 is lowercase, and every other word starts with an uppercase. And we'll console.log this to see what it looks like. Console.log and brackets. So let's save this file and open the console. And that method gave us the time. So for you, you should see your current time here. So that's the built-in date class. It lets us create objects that represent the current date and time. An interesting thing to know is that we used the external library day.js earlier in the project. Day.js uses this date class behind the scenes. However, day.js gives us a lot of extra features, so we usually use day.js instead of using the date class directly. So now let's comment out this code because it was just an example. So at the top, we'll type /* and below it, */. The last thing we're going to learn is more details about this. As a reminder, inside an object, we can use the value this, and this will point to the outer object. So this feature lets an object access its own properties. Now in JavaScript, this can actually be used anywhere in our code. For example, we're going to create some new lines. And here, we can just directly console.log this. So here we're using this, but we're using it outside of any object. In this situation, there's no object for this to point to. So this will be undefined, which actually makes sense. If we save and we check our console, this will equal undefined. Now, originally, this actually equaled the window object. However, this behavior caused confusion. So when they released JavaScript modules, inside a module, this is now undefined, which makes more sense. Let's go back to our code. And another place we can use this is when we're creating an object. So let's go down here, and we're going to create a new object using const. We'll call it object2 and make it equal to curly brackets. And we're going to give this object a property. Let's just call it a : give it a value of 2, comma, and add another property, b : and we'll set the value of this property to this dot a. Now you might think that because we're inside this object, this will point to object 2. However, at this point in the code, object 2 has not been created yet, so this doesn't have anything to point to, and this will be undefined. If we save and then open the console, it will give us an error because this is undefined. Let's go back to our code. So far, if we're inside a method, we can use this, and it will point to the object. If we're outside of a method, there's no object to point to, and this will be undefined. And everything makes sense so far. So let's comment this out using /*, and at the bottom, */. Now the last important place we can use this is inside a function. So at the bottom here, we're going to create a function, and let's call it log this, brackets and curly brackets. And inside, we're just going to console.log this. So again, we're not inside of any object, so there's nothing for this to point to. And in this situation, this will be undefined as well. Below this, if we run the function, log this and brackets, and save, and check the console, it will tell us that this is undefined when it's just inside a regular function. Next, this actually has a special feature. So inside a function, we can change this to whatever we want. To do that, functions have a method called .call. So below this line, let's type the function name log this and use a method .call and brackets. So .call runs this function. So it does the same thing as the line above, except we can set the value of this to be whatever we want. So the first value that we give to .call is going to be the value of this. For example, we can give it the string hello. And now this will run the function, and this will be equal to hello. If we save and open the console, you can see that we set this to be equal to hello. So that's a special feature of this. Inside just a function, we can change this to whatever we want using a method like .call. So .call is the same as calling or running the function, except we add an extra parameter in front. This first parameter is the value of this. The last important thing to know about this is that arrow functions do not change the value of this. For example, below this, let's create a method by using an arrow function this time. So we'll create some new lines, and first we're going to create an object using const. We'll call it object3 equals curly brackets, and inside we'll give it a method and colon, and we're going to create this method using an arrow function this time. Brackets, arrow, and curly brackets. And inside we'll just console.log this. So usually this will point to the object itself. However, arrow functions do not change the value of this. Here, this will have the same value as outside the arrow function. Outside the arrow function, let's type this. Here, this has no object to point to, so this will be undefined. And then inside the arrow function, it will also be undefined. Basically, this keeps the value that it had outside the arrow function. As a test, below this, we'll run object3.method and brackets. If we save and check the console, it will show us that inside here, this is also undefined. So in an arrow function, this will be whatever the value is outside the arrow function. Now you might be wondering, why are arrow functions designed this way? So JavaScript had a common problem in the past. When we are inside a method, this points to the object. But if we try to do a for each loop, inside the for each loop, this does not point to the object anymore. It points to undefined. And that's because we created a whole new function here. And remember, inside a regular function, this becomes undefined. So this caused problems because we no longer had access to the outer object up here. So that's why we created arrow functions. If we replace this with an arrow function, this would be equal to whatever it is outside the arrow function. Arrow functions do not change the value of this. So outside for each, this points to the object, and inside for each, this also points to the object. So that's why arrow functions are designed this way, to avoid accidentally overriding this. So let's summarize what we learned about this. Inside a method, this points to the outer object. Inside a function, this is undefined, but we can change it to whatever we want using something like .call. And arrow functions do not change the value of this. Don't worry if these rules are a bit confusing at first. They are actually sort of reasonable. If there's an object to point to, this will point to that object. If there's no object to point to, this will be undefined. And we have tools like .call and arrow functions to kind of manipulate the value of this to be what we want. The more that you work with it, the more you just get used to it. So now let's comment out this practice code. At the top, we'll type /* and at the bottom, */ and save. And we'll save to Git. We'll open the Git section. Inside products.js, we added some practice code to learn more details about classes and this. Let's type a message describing our changes. Learn more details about classes and this, and commit. Now that we learned object-oriented programming, you might notice that it's a very different style of programming than just writing out a bunch of functions directly. So you might be wondering, which style of programming should we use? Object-oriented programming or procedural programming, which is the step-by-step style that we used in the earlier lessons? The answer is, it's up to you. I personally prefer procedural programming in JavaScript because I think it's simpler. I only use object-oriented programming if I'm working on a team that also uses it. Also, object-oriented programming is much more popular in other languages. So it's still useful to know object-oriented programming in case you work with other programming languages in the future. And that's the end of this lesson. In this lesson, we learned about object-oriented programming, which means we organize our code into objects. We learned how to use a function to generate objects, and we improved that by using a class to generate objects. We learned that classes can have private properties and methods. We learned about inheritance, which lets us reuse code between classes. And we learned about method overriding and polymorphism, which lets us call a method without needing to know what the class is. And lastly, we learned more details about this and how to control the value of this. Thanks for watching this course so far. If you want to support this channel, you can check out the premium version of my courses just like this one, where you can get a certificate of completion and a better learning platform. If you're interested in extra videos from me, more in-depth videos, and behind-the-scenes content, you can check out these links here. You can also support the channel by liking the video, subscribing, and sharing this video with others. Thanks again, and let's continue with the course. Here are some exercises to help you practice what we learned in this lesson. In this lesson, we're going to learn about backend, and this will prepare you for the next step after finishing this course. First of all, what is backend? A backend is just another computer that manages the data of a website. For example, in our Amazon project, we created this website where we can pick which products we want. But how does Amazon, the company, know which products that we ordered? In this situation, there has to be a second computer somewhere that's owned by Amazon. And then our computer sends the order information to this second computer. And now Amazon will know what we ordered. So this second computer is called the backend computer, or just the backend. It manages the data of a website. On the other hand, our computer, or the web page, where we can see and interact with the products, this is called the front end. Now that we know what a backend is, how does our computer, or the front end, send information to the backend? When two computers are connected to the internet, they can actually send messages to each other using a feature called HTTP, or Hypertext Transfer Protocol. In an HTTP message, we can actually attach information, like our Amazon order. When Amazon's backend receives this HTTP message, now Amazon will know what we ordered. Now that we know what HTTP is, let's send our first HTTP message using JavaScript. So we'll go to our code, and on the left, we're going to create a new file just for practicing backend. So we'll scroll up to the data folder, and we'll click inside this folder, and then create a new file. And let's name this file backend-practice.js and press enter. And now to send an HTTP message, we're going to use a class called XML HTTP request. So this is a built-in class, meaning it's provided by JavaScript. First, we'll generate an object using this class, using the code new and the class name XML, all capital HTTP, capital R request, and brackets. So this creates a new HTTP message that we want to send to the backend. A message is also known as a request. So now let's save this request in a variable. At the front, we'll create a variable with const and name it xhr equals this request. Next, we need to set up this request. So we'll create a new line, and to set it up, we'll do xhr dot open and brackets. And to set up this request, we're going to give open two parameters. The first parameter is what type of HTTP message to send. So one type of message we can send is the string get. Get means we want to get some information from the backend. There are several common types of requests that we can give to the backend, but we're going to start by learning get. Next, we're going to give open a second parameter. And this parameter tells the computer where to send this HTTP message. So using HTTP, we can send a message to any computer that's connected to the internet. Now, to locate another computer on the internet, we need to use a URL. URL stands for Uniform Resource Locator, and it's kind of like an address, but for the internet. A URL helps us locate another computer on the internet. So URLs look like this. This is the URL for Amazon, YouTube, and my website. The HTTPS in front means we're using HTTP to communicate with this computer. The S after the HTTP means we're using a secure version of HTTP. The second part of a URL is called a domain name. This is like an address. It points to another computer on the internet. So Amazon.com points to one of Amazon's backend computers. YouTube.com points to one of YouTube's backend computers. And supersimple.dev points to one of my backend computers. If you want to learn more about domain names and how the internet works, you can check out my video on how to put a website on the internet. Now, for this lesson, I actually set up a backend computer that we can practice with. So my backend is located at the URL https supersimplebackend.dev. So in the second parameter of open, we're going to give it a string. And we're going to give it the URL of the backend that we want to send the message to. So the URL for my backend is https:// supersimplebackend.dev. So that's how we set up an HTTP message. We give it the type of message we want to send, and also the URL, which is where to send this message to. The last step is to just send this message. So we'll create a new line, and we'll type xhr.send, brackets, and save. So this creates a new HTTP message, sets it up, and then sends this message across the internet to my backend computer, located at supersimplebackend.dev. So now let's actually run this code and see the result. We're going to go to the left, and we're going to open checkout.js. And in here, just like we did before, we're going to load that practice file that we just created. So we'll create a new line, and we're going to import a file or a string, and we'll locate that practice file. So first we need to go to the data folder using /data/ and load backend-practice.js and save. So we'll go back to the practice file. And now when we open the website, it will run this code and send the HTTP message. To see that, let's open the website. So we'll scroll down. And if you don't have the website open, you can open it again by right-clicking checkout.html and then open with live server. I already have the website open, so I'm going to open it, and then I'm going to go to the checkout page. And now we're going to look at the console. So we'll right-click and inspect. And this time, instead of going to the console tab, we're going to go to a new tab called the network tab. If you don't see this tab, you can make this window wider, or you might find it under these arrows. So we'll open the network tab, And in here, this will show us all the HTTP messages that are coming in and out of our computer. Now, before we start looking at the HTTP messages, there's one important thing to know about the Network tab, and that is messages will only appear here after we open the console. If we send some messages and then we open the console, it's not going to show up here. So to make sure our HTTP messages are recorded here, we need to open the Network tab first, and then we're going to refresh the page to resend those messages. And now if we open the Network tab, we should be able to see the HTTP messages at the bottom. Okay, so inside this list, we should be able to see that we sent a message to supersimplebackend.dev. If you don't see it, we can also search this list by using the text box up here. So in here, we can type part of the URL that we sent the message to. For example, super simple, and the message that we sent should appear here. So now we can click this message to get more details about it. On the right side, we have several tabs here. The Headers tab gives us details about our message or about our request. So it tells us which type of request that we sent, which is GET, and the URL that we sent it to, which is supersimplebackend.dev. This sends the request across the internet to my backend. And then when my backend receives this message or this request, it will send back a message, which is called a response. To see the response from my backend, we can open the Response tab. And you can see that my backend responded with, "Hello, this is SuperSimpleDev's backend," and a documentation page that we can check out. So we have successfully sent an HTTP message or a request to my backend, and we got back a response. Another useful tab here is the Preview tab. It basically takes a response and displays it in an easy to read format. So now let's learn some terminology. When we send a message to the backend, this message is called a request. We are requesting something from the backend. When the backend receives our request, it will send an HTTP message back to us. And this message is called the response. So each request that we make will get one response from the backend. And this is called a request response cycle. It's always one request, one response. Next, currently we're viewing the response in the Network tab, but we can actually get this response in our code and then do something with this response. So let's go back to our code. And here, after we send the request, we can get the response using a property called xhr.response. However, there's a slight problem with doing this. When we send a request to the backend, it takes time for the request to travel across the internet to the backend and for the response to come back. So the response is not available right away, and xhr.response will be undefined at first. So xhr.send is known as asynchronous code. Asynchronous code means it does not wait for this line of code to finish. It just sends the request and then immediately goes to the next line. The response might come back later in the future, but we don't have access to it here. So in this situation, in order to get this response, we need to wait for the response to come back first, and then we can access .response. In order to wait for the response to come back, at the top, after we create the XHR, we're going to use this code, xhr.add capital E event, capital L listener, and brackets. So this method listens or waits for an event, and then it can run a function. So this method takes two parameters. The first parameter is the event that we want to listen for or to wait for. In this case, we want to wait for the response to come back. So we're going to give it the string load. Load means the response has loaded. The second parameter is a function that we want to run after this event happens. So in this case, after the response has loaded, we're going to run a function. Brackets, arrow, and curly brackets. So because this function runs after the response loaded, inside here, we can access xhr.response. And this will not be undefined. It will contain the response that we saw earlier in the network tab. So let's console.log this to see what it looks like. Console.log and brackets. And we'll remove this line at the end. And save. So now let's go back and check the console for the response. So we'll open the console and then open the console tab. And here you can see that we have the response in our code and we console.logged it. So this response is a string. And now we can save this in a variable or do whatever we want with it in our code. Now, one thing you might be wondering is why do we put the event listener up here at the top? So first, we need to set up the event listener and then trigger the event or send the request. This is the same as setting up an event listener for clicking a button. We need to set up the event listener first, and then we click the button after. So that's how we send a request to the backend, wait for the response, and then save the response in our code. Next, we can send different messages or different requests to the backend using URL paths. A URL path is the part that comes after the domain name. For example, in this URL, the URL path is /hello. In this URL, the URL path is /products/first. In this URL, if there is no URL path, the URL path is /. We can send a request to these URL paths, and each URL path will give us a different response. So let's try sending requests to different URL paths and see what different responses that we get. So for this example, let's send the request to supersimplebackend.dev and then the URL path /hello and save. And now let's open our console to see the response. And here you can see that this URL path gave us a different response than last time. Let's go back and try another URL path to see what it looks like. So we'll delete this and then send the request to /products/first and save. And we'll open the console to view the response. And here, this URL path gave us a JSON, and this contains the details of the first product in our Amazon project. So we can send requests to different URL paths, and we will get different responses from the backend. Next, a backend only supports a certain set of URL paths. For example, when I created my backend, supersimplebackend.dev, I had to decide which URL paths are supported and how my backend would respond to each URL path. If we send a request to a URL path that is not supported, the backend will respond with an error. let's go back to our code and we'll try a URL path that is not supported. So let's remove this at the end and we'll try sending the request to not dash supported and save. And now if we look at our console, you'll see that the backend responded with an error message saying this URL path is not supported. The browser will also console.log this red error message. This red message is displayed automatically when there's an error. So this message tells us the type of request that we sent, which is GET, and the URL that we sent it to, and also this number, which is called the status code. Whenever we get a response from the backend also gives us a status code, which tells us if a request succeeded or failed. A status code that starts with 4 or 5 means the response failed. Starting with 4 means it was our problem. We sent the request to a URL path that was not supported. Starting with 5 means it was the backend's problem. For example, the backend crashed. A status code starting with a 2 means the response was successful. So we can also see the status code in the network tab. So we can search for our request, and then when we click the request, in the headers tab, it will show us the status code in this row. So this tells us if our request succeeded or failed. So now you might be wondering, how do we know which URL paths are supported and which are not? So there's actually no way to figure out all the URL paths that are supported, and this is for security reasons. However, some backends do provide a documentation page that lists the URL paths that are supported and also what kind of response that they give. For my backend, I created a documentation page, and we're going to take a look at that. So we'll open the browser, and at the top, we're going to create a new tab. And to see the documentation for my backend, we're going to go to super simple backend.dev/documentation and press enter. So this is the documentation page for my backend. It gives us a list of which URL paths that are supported and what each URL path does. So when we make a request to /, it will give us this message, which we saw earlier. If we make a request to /hello, it will give us this message, which we also saw earlier. So by the way, the list of all the URL paths that are supported is called the backend API. API means Application Programming Interface. Interface means how we interact with something. So this list of URL paths are all the ways that we can interact with the backend. And that's why we call this the backend API. Next, the backend can respond with different types of data. So one type of data the backend can respond with is text. For example, when we sent the request to get/hello, it gave us some text back. So in our code, if we change this URL path to /hello and save, and we open the console and click the console tab, it gives us back some text. We can also see what type of response that we got using the network tab. So we'll open the network tab and then search for the request. And then here, when we click it, inside the headers tab, if we scroll down to the response section, here it will give us the content type or the type of response that we got back. So in this example, /hello gave us some text, and the type is text/plain. Another type of data the backend can respond with is JSON. So if we go back to our code and change the URL path to products/first and save, and then look at our console, in the network tab, we'll open this request, and inside the headers, if we scroll down, it will tell us that the type of the response is application/JSON. So the backend sent us back some JSON. If we open the console tab, we can see the JSON string here. So once we get this JSON from the backend, we can use json.parse to convert this back into a JavaScript object. Basically, this allows us to send JavaScript objects across the internet to the backend. Another type of data the backend can respond with is HTML. We'll go back to our code and we'll change the URL path to documentation. So this was the documentation page that we saw earlier. If we save and then open the console, you'll see that the backend responded with a bunch of HTML. If we look at the network tab and search for the request and open the request here, and in the headers tab, we scroll down to the content type, it will tell us that the type of the response was text/HTML. Finally, another type of data the backend can respond with is an image. For example, we'll go back to our code and change the URL path to images/apple.jpg and save. And we'll open the console. And in the network tab, we can open this request. And in the headers tab, we can scroll down and it will tell us that the type of response was an image/JPEG. As you can see, the backend can respond with different types of data, not just text. Okay, so we got this image back from the backend, but what does this look like in the console? We'll open the console, and we'll see that we just get a bunch of random characters here. And that's because the console is trying to display the image as text, but the image is not really text. This is the image's raw data, so that's why it shows all these random characters here. However, it would be better to display this as an actual image instead of raw data. We can display this as an image by using the browser. So if we open the browser, when we type a URL at the top of the browser, it actually sends a GET request to that URL. So typing in here actually does the same thing as our code. It makes a GET request. The one big difference is that in the browser, when it gets back the response, it will display the response on the page. For example, if we enter supersimplebackend.dev and change the URL path to just nothing or slash and press enter, this actually sends a GET request to my backend. The backend responds with some text